This video is going to be about using the empirical rules to find the percentage of items under a normal curve, given the mean and standard deviation. Whenever you're using the empirical rule, you will be given the mean and standard deviation. And the first thing that I always do is I get out a piece of paper and draw pictures before I even read any of the questions. So we're going to do that. All right, so I drew a normal curve. Mine are never super pretty or symmetric. We just have to use our imagination and pretend like it's symmetric, like they are in the books. We're going to first indicate where the mean is. Right here in the middle is your mean. They say that the mean is 20 pounds of this imaginary melon that doesn't exist. That's the mean. There's your symbol for mean. And in a normal distribution, the mean, the median, and the mode are all in the same place. Median, mode. The most frequent sized winter melon is 20 pounds. If you line up all the winter melons from the lightest one to the heaviest one, the one in the middle is going to be a 20-pound winter melon. So mean, median, and mode are all going to be the same here. And then the next thing they gave us the mean is 20 and the standard deviation is 4. So we're going to go out 4 pounds right here. This was our mean plus 1 standard deviation, or 20 plus 4, 24-pound winter melon. And we're going to go down 4 pounds. This is our mean minus 1 standard deviation, or 20 minus 4, which is 16. And what we know from the empirical rules is that 68% of all of our winter melons are going to weigh between 16 and 24 pounds. You read that in your book before watching this video, hopefully. 68% of the winter melons are going to weigh between 16 and 24 pounds. Next, we're going to go out another standard deviation. Over here, we're going to go down. This is going to be the mean minus 2 standard deviations, or 20 minus 2 times 4, or 20 minus 8, or 16 minus 4, because you're just going down 4 more. So that's a 12-pound winter melon. And then we'll go up 4 more pounds, and here's where my lack of symmetry is definitely starting to get me. So this is the mean plus 2 standard deviations. In this case, it's 20 plus 2 times 4, which is 28, and I'm trying to make that fit. Hopefully you can read that. I think it's legible enough. And from the empirical rules that you read in the book, we know that 95% of all winter melons weigh between 12 and 28 pounds. We're going to go out 1 more standard deviation and get almost all of our winter melons included here. Right here, we're going to go the mean minus 3 standard deviations, or 20 minus 3 times 4, 20 minus 12, which is 8, or 12 minus 4, because we're just going down 4 more. So 8-pound winter melon is a pretty small winter melon. There also are some that are smaller. The normal curve goes on beyond that. And then we're going to go here. This is the mean plus 3 standard deviations, and the mean is 20, and we're adding 3 times 4, so we're adding 12, and 20 plus 12 is a 32-pound winter melon, which is a big winter melon. So in between those two weights, we know from the empirical rules that 99.7% of all winter melons weigh between 8 and 32 pounds. That's true of anything that's normally distributed with these standard deviations. So let's start looking at the problems. So the first couple questions are pretty straightforward. The first one asks us what percentage weigh between 16 and 24 pounds. And once you've drawn the picture, it just kind of screams at you. It's 68% that are between 16 and 24 pounds. Next, we'll look at question B, between 12 and 28 pounds. Again, here, between 12 and 28 pounds, that's minus 2 standard deviations to plus 2 standard deviations that we're just reading right off of the empirical rules. And we can see that there's 95% of the melons between these two zones. Next, this worksheet asks between 8 and 32 pounds. And again, this is reading straight from the table. Almost all winter melons weigh between 8 and 32 pounds. So we're just going to write that in. For parts A, B, and C, everything was just there and readable. And now it's asking us what percentage of these melons weigh less than 20 pounds. Here's 20 pounds. It's our mean or our average, but it's also our median and our mode. And the median is the information that's most useful here for this one. So for less than 20 pounds, they're saying less than the mean, median, and mode. And the median, if you remember, is the middle. So if it's less than the middle, then that's half, 50%. So normal curves are normally distributed. They're symmetric. There's all sorts of beauty in that. So I have another version of this. I'm going to just kind of shade it in here. So 50%, or just show you, like, if it's just half. If I drew neatly, like, actually that's pretty close for me. So 50% of the data is over there. The next one's going to get a little harder, and we'll need a little more paper to draw on. Let's go. If you have not drawn this curve for yourself yet while you're watching this video, I strongly suggest you draw everything out. Pause the video, make sure you've drawn at least this curve. Do not worry too much about what it looks like. It is nice when it doesn't go like this and it goes like that, to show that there really is stuff beyond here. There's really huge winter melons, not very many of them, and really teeny winter melons, but not very many of them. So draw the curve, and then we're going to go on to part E. Now we're going to look at what part or what percentage of the winter melons weigh less than 12 pounds. And I'm going to draw a little curve right underneath here. And it's never as good as the original one. Yeah, that's pretty bad, but don't worry about it. Like, it's fine. So as long as you have the original one looking kind of okay. So the ones that weigh less than 12 pounds are the little ones. Okay, there's a couple different ways to deal with finding this area. So less than 12 pounds, I want you to get a picture of kind of what it is. It's going to be a small number, and the 12 pounds was the mu minus 2 standard deviations. So a couple things that we do know is we know that 95% of all pumpkins weigh between 12 and 28. So if we get rid of those guys, the 95%, let's say we're getting rid of those, we have these two tails. So if 95% is in between, let's put in our 28, and here's looking at the tails. If 95% is in here, 95% is in here, then what's left of 100% is 5%. So 5% then is remaining outside of there. I can't find the pencil I want. Okay, let's do this. So that means that out here, the tails comprise 5% of the data. So 5% of the winter melons weigh less than 12 or more than 28 pounds. So, and the other thing about the symmetry, remember we folded in half a little while ago, is that this tail, even though my drawing doesn't show it, and this tail are the same size, which means that this tail over here is half of the 5%. So 1/2 of 5%. And half of 5% is 2.5%. And I feel like I need one more color and I'm not finding it, but I'll use this. So this little tail over here is 2.5%, a teeny weeny piece of the data. So I hope that makes sense, and drawing it really helps the numbers make sense. It's just a teeny bit. There's only a teeny bit of teeny winter melons. Okay, so now we got that little tail done. We're going to move on to the next question. That was part E. We're going to move on to part F. So for part F, we're looking at what percentage weigh more than 12 pounds rather than less. So rather than this teeny little tail over here, we're looking at all the rest of them. So we're just saying, teeny guys, we don't want you little teeny winter melons. We want all the rest of you. There's two ways to look at this, and I'm going to draw pictures to depict both of them. One way is, knowing that we have this, you can look at the entire normal curve. Oh, you can see through. Not too bad. You can look at the entire normal curve, and under the entire normal curve is 100% of your data. Okay, and we can just chop off this little 2.5% guy over here. We can get rid of him, cut him off, get rid of him, subtract him. Some people like to draw this and then subtract it, and so just have, this is horrible, normal curves. So don't worry about what yours look like, really. So that means the rest of this is the 100% minus the 2.5%. 100% minus 2.5%. And that is 97.5%. The other way that you can look at it also is you can look at this guy again and know that we don't want that, but we do want the 95% in the middle and the little 2.5% up here in the tail up here. So either way, 95 plus 2.5%, which gives you 97.5%, or 100% all of it minus that tail over there gives you just the 97.5%. So it's a complement. We did complements when we did sets, and here's another complement. All minus some is what's left, and this time what's left is a lot. All right, we have one more puzzle left. Now we're looking at between 12, whoops, it's windy, between 12 and 24 pounds here. 12 to 28 is given to us, but not 12 to 24. There's a couple different ways to look at this one. And I always like to use the symmetry. So I'm going to show you one way, and you can probably think of other ways to do it as well. Let's look at the things that we know. So here's sort of the normal curve, hopefully. We've got 12 to 20, and we've got 20 to 24. So this is minus 2 standard deviations, and this is plus 1. So in using the symmetry, we know that 12 to 20 is half of this green 95%. So let's do 1/2 of 95%. And then 20 to 24 is 1/2 of that 68%. 1/2 of 68%. So let's find those values and add them up. Half of the 95%, stick in your calculator, do whatever you want to do, gives you 47.5%, and half of the 68% gives you 34% to here. So there's your 12, which was the minus 2, and your 34, which was the plus 1. I'm going to color code them to go with the colors we had above. We add those two up, and when we add them up, we get 81.5%, 81, which hopefully makes sense because it's got to be more than 68%, because it's wider than that. We've got this extra little chunk over here that's not even that little. So 81.5% hopefully feels right. Hopefully drawing these pictures will help you figure out the normal curve things. If you have access to a printer, I strongly recommend you printing out this entire worksheet and drawing the pictures right along with the worksheet, because that's where it'll make the most sense. Oh, and I can't have it angled right, but hopefully that makes sense.